Hello students, I welcome you to my channel. This is second class. If you have missed the first class, you better listen that if you don't have any concept related to the topic. So this is two-dimensional motion or projectile motion. Let us derive some formula related to projectile motion. Uh, Before this you have learned one-dimensional motion. So on the basic formula in one-dimensional motion or acceleration is equal to v minus u by t. So this is what v minus u is actually change in velocity, and v minus u by t will give you change in velocity per unit time, right? Therefore, you define acceleration as rate of change of velocity, right? So rate of change of velocity is acceleration. The same formula when t goes this side will become a into t, and minus u when comes this side will become u plus u. So u plus at is equal to v, right? So the both are same formula. Actually the both are same formula, but they look different. So here subject is here subject is v, right? And the main basic formula in this entire kinematics is average velocity is equal to displacement by time. Basing on this formula only, these two formulas are derived. Means this formula and this formula are used to derive these two formulas, right? But when you learn, we learn mainly 1, 2, 3 only. Remember the three formulae. Displacement is equal to ut plus half at square, and v square minus u square is equal to 2as. They are the basic formula. You must be thorough about them, right? Now, for the object from the point of projection to reach the maximum height for the object, some time will take, isn't it? The time is called time of ascent, right? So nothing but time of ascent is defined as the time required for the object to reach from the point of projection to maximum height, right? So for calculating time of ascent, we use the formula v is equal to u plus at, right? So now you have to know that as the object is going in the upward direction, as here you see the other video, right? So as the object is going also in the upward direction, when we calculate anything related to upward direction, right, downward direction, so we have to take velocities as vertical component of velocity. You should not take horizontal component of velocity, right? When you consider the distances in or anything in the horizontal direction, you take horizontal component of velocity, right? That is why, so here maximum height we are calculating, so nothing but time of ascent we are calculating. So we have to use the formula v is equal to u plus at, and t will become time of ascent. As the object is going in the upward direction, we take a as minus g, acceleration due to gravity it is, and u as uy. Uy means vertical component of velocity here. So this is the final velocity, right? So this equation will give you the final velocity of the object at any point here, right? At any point, this formula will give you the velocity of the object at any point in its path. This is general formula. But at the maximum height, t is equal to time of ascent, we will substitute, and at the maximum height, vertical component of velocity becomes 0. You know already, when the object is going in the upward direction, the velocity of the object gradually decreases, and at the maximum height the velocity becomes 0. So that is why we take final velocity as 0 at this point. So under uy, vertical component of velocity is u sin theta, right? So minus gta as this. So minus gta, if you bring it to the left side, will become 0 plus gta. So 0 plus gta is gta, right? And gta is equal to u sin theta. So ta becomes what? Time of ascent becomes u sin theta by g, right? Remember, right? So this formula you must keep in mind, u sin theta by g. So when the problem is given, you can use the formula directly, right, for time of ascent. So moreover, time of descent now, from the maximum height to reach again the ground, for the object some time is required now. That is called time of descent. Time of descent and time of ascent, by uniformity you can say both will be same, but we have to prove that, right? So before we take the main right, we first of all we calculate maximum height reached by the object. So how to calculate maximum height, right? Again, maximum height means the velocity you have to consider only in the vertical direction, not in the horizontal direction, right? So that you have to remember. And g will be, so ut plus half at square, use this formula. A will become minus g, and velocity you should take vertical component of velocity only. So maximum height, u sin at maximum height, for the object to reach some maximum height, some time is taken, no? That we have substituted from this time of ascent, we have substituted here, right? So u sin theta into u sin theta. So uy, this is vertical component of velocity. So right here u sin theta, time of ascent it is, right? Maximum height it is. So we are substituting here t as ta, u sin theta by g minus half into g into t square, u sin theta by g whole square, right? So u into u square, sin theta into sin theta, sin square theta by g minus half into u sin theta by g whole square, u square sin square theta by g square, g and g square, one g will get cancelled in the denominator, so remains u square sin square theta by g will remain and half as it is, right? So now this, there is 1 here, there is half here, this remaining thing is same, u square sin square theta by g, u square sin square theta by g, this is what, x minus half x, right? You will remain with half x, that is what, half u square sin square theta by g. Is it clear? So that is what maximum height reached by the object is u square sin square theta by 2g, right? Now let us consider that object is at maximum height. As we discussed earlier, at maximum height the vertical component of velocity becomes 0, and as it is coming down, the vertical component of velocity gradually increases, and there will be some vertical component of velocity for the object when it is touching the ground. Let that be Vy. And when the object reaching from maximum height to this again ground, for reaching from maximum height to ground, it will take some time for the object, right? So let that be, that is called time of descent. Let that be time of, let us indicate it by Td. And the maximum height reached by the object is h is equal to u square sin square theta by 2g. Just now we have calculated, right? So remember that. So now we use two formulae again here to calculate time of descent and to calculate Vy when it is reaching the ground, right? So we use the formula V is equal to u plus at again. So in this case now, so initial velocity uy is 0 and v is when it reaching the ground, v is equal to vy, right? So vy is equal to 0 plus a, as the object is coming down, acceleration will be taken as plus g. So gtd, right? Gtd. So implies td is equal to 0 plus gtd is gtd, and td becomes vy by g. Vy is the velocity of the object when reaching the ground. Now let us take another formula, v square minus u square is equal to 2as, right? So implies v again, the velocity of the object when reaching the ground, uy is the initial velocity at maximum height, and a is actually plus g, and displacement here you have to take this maximum height, right? So as the object reaching, when the object reaches from the maximum height to the ground again, it covers a displacement of again from the maximum height to ground, right? You have to take u square sin square theta by 2g. Therefore v becomes vy square minus 0 square is equal to 2 into g into u square sin square theta by 2g, right? So 2 cancel, g cancel, right? Vy square minus 0 square is 0 only, vy square minus 0 square, you get only vy square, right? So you will remain with the v square is equal to u square sin square theta, right? So the magnitude of vertical component of velocity when reaching the ground same as its velocity at the time of projection, right? Magnitude only, not direction. So you can take as vy is equal to plus or minus u sine theta. So when you take square root here, you take plus or minus here. So as Vy square is positive, this is also positive only. But even the value u sine theta value is negative, on squaring it you will take positive one, isn't it? So that is why, right? For example, if you for understanding, if x square is equal to 4, x square is equal to 2 square, but we have to take x as a plus or minus 2. If x value is plus 2, x square value is 4. If x value is minus 2, also x value is 4 only. That is why x Vy is equal to plus or minus u sin theta, nothing but magnitude of velocity at both the points will be same, vertical component of velocity. That is why Vy is equal to magnitude we take, no? That is why Vy is equal to again what? Magnitude of Uy at the point of projection, right? So that is why it is again what? U sin theta by g. Therefore, time of descent is equal to time of ascent, right? So in next session we continue, we calculate horizontal distance, and we go in Olympiad level, we calculate some problems.